Hello students, today we are going to learn one of the important article from topic electrochemistry. Today we are going to learn dry cell. Now, dry cell, as you know, it is a voltaic cell. It is also called as galvanic cell. It is used to produce electric current. You know very well, dry cell is a non-rechargeable cell, hence it is called as primary cell. So, here I am carrying this one of the dry cell. You know very well, Nippo, ever ready, these cells you use for the sake of charging your battery, using torches, using toys, playing toys, or you are using this in a wall clock. Today we are going to see how does this cell exactly functions. Alright, let's get started. देखिए यहाँ पे हमने सेल के डायग्राम बनाई हुई है. यहाँ पे you can relate yourself, इस सेल को आप इस डायग्राम से रिलेट कर सकते हो. ये जो आउटर कवरिंग है, it is made up of zinc. ओके तो ये है जिंक कंटेनर, आप यहाँ पे देख सकते हो. दिस आउटर कवरिंग विच इज मेड बाय रेड दिस ब्लैक लाइनिंग, दिस इज अ वेसल विच इज मेड अप ऑफ जिंक, सो इट इज कॉल्ड एज जिंक कंटेनर. द लेयर विच इज प्लेस्ड इनसाइड, इट इज अ प्लास्टिक पेपर जिसको हम कहते हैं पेपर स्पेसर. ऑलराइट, ये जो जिंक लेयर के अंदर जो एक लेयर होता है प्लास्टिक का, विच इज जस्ट यूज्ड टू सेपरेट इलेक्ट्रोलाइट फ्रॉम द पर्टिकुलर इलेक्ट्रोड, दैट इज कॉल्ड एज पेपर स्पेसर. ऑलराइट, इस सेल के बीचों बीच एक ग्राफाइट की रॉड होती है, जो आपको पता है. ये ग्राफाइट की रॉड एक्ट होती है एज अ कैथोड, जिसके ऊपर यहां पे ब्रास कैप बिठाई हुई होती है. ऑलराइट, इसके अंदर आपको अगर आप देखोगे केमिकल यहां पे दो चीजों में भरी हुई है. अंदर की जो रेडिश कलर की लेयर है, जो मैंने रेडिश कलर से बताई है, विच इज नथिंग बट पेस्ट ऑफ MnO2 एंड कार्बन. और उसके बाहर जो लेयर है, जो अपनी एग्जैक्ट इलेक्ट्रोलाइट है, उसे हम कहते हैं ZnCl2 plus NH4Cl. This cell is first of all constructed by scientist Lagrange's, so it is also called as Lagrange's cell. And the electrolyte is not exactly dry, but most of the components are in a dry mode. That's what it is called as dry cell. All right? तो अभी हम देखने वाले ये सेल exactly work कैसे होता है. आपको पता है एनोड पे होना है ऑक्सीडेशन, कैथोड पे होना है रिडक्शन. इलेक्ट्रॉन रिच स्पेसीज विल लूज इलेक्ट्रॉन एंड इलेक्ट्रॉन डेफिशिएंट स्पेसीज विल गेन इलेक्ट्रॉन. जो इलेक्ट्रॉन लूज करेगा वो ऑक्सीडाइज होगा, जो इलेक्ट्रॉन लूज गेन करेगा वो रिड्यूस होगा. ऑलराइट, सो ऑक्सीडेशन इज गोइंग टू ऑकर एट एनोड एंड आवर एनोड इज नथिंग बट कंटेनर ऑफ जिंक. सो हाउ इट इज गोइंग टू एक्ट, लेट्स सी ओवर हियर. नाउ एट एनोड द surface of zinc is going to lose the electron. Okay, let me write it again. And it is going to produce zinc 2 plus ions with a release of 2 electrons. Alright, very simple oxidation reaction you can understand. Now, these electrons which are lost by the zinc container at the place of anode will be moving across the wire. Alright, जैसे कि आप यहाँ पे मशीन मोटर लगाते हो, है ना, और दो वायर आप यहाँ पे अटैच करते हो ब्रास कैप से, है ना. तो electrons are simply moving across this wire which are simply moved out at the cost of oxidation. And these electrons will move over here. Externally, it will simply function our motor or whatever appliance we are attaching, and then it will move over here. It will come over here at the positive terminal, which is known as cathode, which is simply connected with a brass cap, and it will simply move inside. So here we go with the electrolyte. Now, just remember, paste of MnO2 and carbon is just used for some other concern. It is nowhere electrolyte. I'll explain you soon. Wherein this paste of zinc chloride and ammonium chloride is collectively called as electrolyte. So what is going to happen now? You know very well, in this particular electrolyte NH4Cl, it will simply dissociate. Being electrolyte, it will dissociate into ammonium plus ammonium and chloride ions. So tell me, which among two is electron deficient? Yes, it is, but obviously cationic species. Alright, so cationic species will gain the electron and it will undergo reduction. Let's see how it goes. Alright, look at this. These ammonium ions, which are acting as an electrolyte, will simply gain electron. Alright, so just for the sake of balancing, I will write 2 over here plus 2 electrons. And what it will produce? It will produce formation of ammonia plus it will release hydrogen gas. Got it? So we have understood the reaction occurring at anode, that is oxidation, where we find loss of electron, and the electrons lost by the anode are migrating towards cathode via external circuit, that is nothing but flow of current we are observing, and then these electrons are being absorbed by the electrolyte so as to undergo reduction reaction, and we are finding this reaction. Now you know very well, hydrogen is said to be explosive and it may cause explosion, and for that sake we need to digest this hydrogen. So here there comes a role of this pest. Now what happens, you know, this MnO2 which is placed inside the electrolyte will simply come in contact with this H2 and it will turn hydrogen gas into water like this. Look at this. It will turn Mn2O3 plus H2O. For the sake of balancing, I'll just put 2 over here. Now the thing is balanced. So now this is anodic reaction, but these two reactions are the cathodic reactions. So as to get the overall reaction, I must add both the reactions. And you know very well how to add chemical reactions. We just cancel common factors on opposite sides. So let's do it. This hydrogen will get cancelled and we'll get the reaction 2 ammonium ions plus 2 MnO2 plus 2 electrons. It will produce 2 ammonia plus Mn2O3 plus H2. Alright. Now this is overall reaction occurring at the cathode, and we know our previous reaction Zn goes on giving Zn2 plus 2 electron is occurring at anode, and that's what, so as to get NCr. What is NCr? It is net cell reaction. What we are supposed to do by the fundamental principle, we are supposed to cancel the number of free electrons lying on opposite side, so you can simply cancel these 2 electrons with these 2. Now just add both the reactions and just let's write this Zn plus 2 ammonium plus 2 MnO2 will give us, yes, it will give us Zn2 plus 2 ammonia plus it will give us Mn2O3 plus it will give us water. Alright. So this particular reaction is nothing but reaction which is occurring inside the primary galvanic cell, which is called as dry cell. So when these reactions are occurring within the cell, the electrons are flown through external circuit. ध्यान रखिएगा, ये जिंक के कंटेनर से being anode, oxidation reaction होने के बाद electrons will move out, it will migrate, it will travel its journey through external supply, within which we are joining our appliances so as to get the electric uses, and then these electrons will move back to the positive terminal, from where it will move into electrolyte and the further reactions will occur. So remember, once the chemicals are consumed, you cannot regenerate this chemical back, as how you can do it in a chargeable cell. Alright, and that's what these cells are known as primary cell. ये cell का main use आप कर सकते हो टॉर्चेस में, इसको आप यूज कर सकते हो टॉयज में, इसको आप यूज कर सकते हो वॉल क्लॉक में. So this cell has limited use that once they discharged, you cannot recharge it. Alright, thank you so much.